Hello, this is David Braun with Automated Valuation Technologies. I want to address a question that an appraiser asked me. He said that he used a predictive modeling technique that displayed R squared, and he felt like he had a really good value, good data, and good analysis, and he felt like he had it well supported with mathematical predictive analysis techniques. And the reviewer saw the R squared was below 0.7 and said, I'm going to fail the appraisal. And his question is, to me, the appraisers, is 0.7 a good threshold? All right. Now, to do this, we're going to look at some mathematical evidence. We're not going to take it out of a book. And we're not going to cover everything about R squared. I'm trying to keep this video to less than 10 minutes. But I do want to give you a commercial. You need to get the book, The Valuation Analyst, Research and Extracting Adjustment Rates, because we do the same kind of mathematical analysis on the various extraction methods to see if they're useful and reliable or they're not. But let's get back to our question. We want to mathematically decide, is 0.7 a good R squared to use as a threshold to judge the accuracy or reliability of a predicted price of a home? So in this case, to do this, we're going to need a few things. We're going to need a hypothetical market. We're going to need some type of a market modeling analysis. We're also going to need to have a subject property. So we've got these three things here. Now let me move this down. This at the bottom. We'll get to this in a minute. Don't worry so much about this right now. Now our model, it has a few things in it to make it work in a minute when we get to this law of large numbers down here. We're going to want it to vary sometimes. These not always be the same number. And the coefficient, the market's coefficient, like 155. So what we know here is we're only looking at one variable, gross living area. So this is like 1869 times $155. That's going to give us $289,695. Now, that's the real intrinsic price. People say, what's the intrinsic price? Well, that's what the math should be. Now, in a real market, buyers and sellers set the price, and sometimes it's different. In this case, I'm using a randomness of a plus or minus 20%. So this sales price is based on the intrinsic price with randomly added in plus or minus 20%. Up here is the formula that I used for it. Here's the formula that ran between here and the coefficient changes. Of course, they'll always be the same. Now, the model, the technique we're using here is simple linear regression. And what we've used here is the forecast function in Excel. The forecast function in Excel relies on the sum of the least squares. So it is a simple regression in this case, since we're only using one variable, gross living area. So then it's going to give a prediction for each of these. So the prediction then is based on the actual gross living area of the sales and the actual prices. So you'll see that's column B and column E, and that's why I left these columns open. You can see we're talking about columns B and E, and that's the answer. Now, we also, then we look at our model, we want to know what the R squared is. So what is R squared? Well, R squared is simply R, the true R, which is the correlation coefficient, squared. A lot of people think of R squared like its own animal. You're better off to think of it as R, the correlation coefficient, squared. Okay? So when we say that, what columns are we looking at? Well, here we're looking at the actual price, column E, as compared to the predicted price. Okay? And in this case, the R was 0.8554. And when we square that, we get 0.73. So in this case, this would be an answer that's above the 0.7 threshold. Now, in order to test this, we got to have a subject property, and in this case, it changes each time I hit the run button to give some different perspective. But 1674 times 55. So we know the correct answer is 259. Now the model, the same way the simple regression predicted for comp 1, it predicts for the subject. It got 243. Now I know what the actual, then we can calculate the actual error in the intrinsic price of the subject and what the model predicted, and in this case it's 6%. Okay, so 259 to 243, it's off 6%. The sales price is 6% higher than the prediction. Okay, so I can run this again, and when I run it again, things scramble around. In this case, let's just look at one now. Is this R squared above our threshold? And our threshold for the R squared is 0.7, so it's good. And so the reviewer would say it's 0.7. I'm going to tend to pass this predicted price, that the predicted price is reasonable. And he would be correct, or she, because it's 1.4%. In other words, it predicted very closely. So that rule would help. Now, here's one. This one didn't work so well because this is a failed R squared. You see that? It's 0.29. It's not anywhere near 0.7. So the answer should be wrong, but look, the answer is really close. It's less than 1% off. So in this case, the reviewer, if they used the 0.7%, would get a false positive. The reviewer would get a false positive on this. Now, one thing we've got to set another threshold is, when is this a bad answer? Okay, 3.5% is good. We use 5. But let's get a little bit extreme, and let's say, and I've used it down here as 10%, let's say 10% is a bad answer. We know that if you flip a coin 2 or 3 times, you might get all heads, and it would be a misleading that you'd say, oh, that coin always gives heads. But then the next time you flip it, it might give you a tail because maybe the coin is really a 50-50 coin. In this case, we want to get to large numbers, which means if you flip that coin 10,000 times, if it's a fair coin, it's going to be heads about half the time, pretty close to half the time, and tails half the time. So we want to get into large numbers, and we're going to run this 1,000 times. And what I've done, I've set a little loop. So like where this runs once and we get these answers, we're going to run this. It's going to run 1,000 times, and for each time it runs, for each run, it's going to record the R squared and the actual error in the predicted price for the subject property. So let's run it, and let's see what our answer is. Okay, so in this case, let's look at the first one. We got a good answer because we're over 70% and we're within the plus or minus 10%. Let's find a bad answer just to see how this works. Okay, in this case, the R squared is less than 0.7. If the reviewer fails it or tends to fail it based on that, the real answer was 5%. The reviewer would be wrong. It gave a false negative. Now let's find a false positive real quick, just so you're clear on what a false positive is. A false positive is the reviewer says, oh, we got a 0.83 R squared. I'm going to tend to believe that the predicted price that the analyst used is reasonable, but look, it's 13% off. So when we ran this, what we found out, and we ran it 1,000 times, 361 times, we got false negatives, okay, based on the 70% and 10% thresholds. We got 59% false positives. And when we base these numbers on 1,000, the reviewer was wrong 42% of the time. So the reviewer's wrong 42% of the time. So we can answer now the question that we had, is 70% a good threshold to use? And the answer is no. All right, what about 60%? So let's hit 60% and run it. Now you're wrong 21% of the time. Ooh, 1 out of 5 you're wrong. Probably the R squared is not a good tool. It's not a good output to use to judge the accuracy or reliability of the predicted price. Or I've not given evidence that R squared is not a good model building tool, but I'm given mathematical evidence that it is a poor test of the accuracy of the predicted price.